Alright, so area enclosed by the x-axis, so these will be all definite integrals. Okay, so we've learnt the skills on just how to integrate. Then now the application of that, and one of the main things you'll be doing involving integration is to find the area enclosed by a curve and the axis. So most of your questions will be curved and finding the area underneath the curve and the x-axis. Alright, we will be moving on next lesson into looking at areas bounded by the y-axis as well, okay, and how we need to change a couple of things so that we can find the area, but we'll just focus on the startup here. So the definite integrals that we've done, okay, so we knew the endpoints of integration and we had a number resulting at the end. Okay, so when you are to calculate the area, you should obtain a positive answer because an area is a positive quantity. Alright, so we need to also remember to include the units. Alright, so that's one other thing we need to do from what we've done already. Is when we had the integration, we've integrated, got a number, you need to write units squared. Alright, to include your answer. So, areas above the x-axis, so you've got a curve above the x-axis. Okay, so the area above, bounded by the curve and the x-axis, will give a positive definite integral. Okay, areas below the x-axis will give a negative definite integral. Okay, so in other words, if you have some curve and it's below the x-axis between your bounds of integration of a and b, right, what we need to do is take the absolute value of that definite integral to give you your positive area. Okay, right, so let's do some questions. When we are calculating area, it is highly recommended that you do a sketch. So, examples A. You need to find the area enclosed by the line y equals x. The x-axis and the line x is 4. Alright, so we need to find the area that's bounded by those three conditions. So the first thing you need to do when you are calculating area, and we are leading into volume as well, okay, is to sketch the area to be found. Now this is just a rough sketch, you're not getting marked in the sketch, so just a quick sketch of the curve. In this case we've got the straight line y equals x. I'm just drawing in the first quadrant because x equals 4 is in the first quadrant. Okay, so I don't need to do the whole curve, just up to the point that I need. Okay, so there's the line x equals 4, it cuts the x-axis at 4. So there's x-axis here, there's of course the origin where the line goes through, and we are finding that shaded area, okay, which is a, what shape? Triangle. So we're already finding the area of that triangle. Okay, so what's the area of that triangle? Just using your triangle formula. Okay, so the area of the triangle is 8 units squared. So when we do the integration, we should get the same answer, shouldn't we? Right, so the area, capital A, is the integral from the endpoints of integration. So the highest point goes up on top and the lowest point goes on the bottom of the function. So this is f of x is x. So we're integrating x and then we write dx at the end because that gives us a notation of what we need to integrate with respect to. Okay, so what's the integral of x? X squared over 2. Alright, parentheses and the endpoint at the end of the parentheses. So remember the fundamental theorem of calculus. So to integrate x, we do the primitive function of b, take away the primitive function at a. Right, that is the fundamental theorem of calculus. So equals, so substitute 4 in for x, it'll be 4 squared on 2. Take away, now get in the habit, put the brackets there, always, because when you have more than one term, which we'll have coming up soon, right, you need to have the bracket. then 0 squared on 2. Now, you can really just write 0 if you know that's going to return 0. Okay, because I know I substitute 0, going to be 0, 0, 0 divided by 2. I can just put 0 there. I don't have to show the full substitution. So 4 squared 16, 16 divided by 2 is 8, okay, which matches what I've got there already. And you need to include your units, alright, 8 units squared. So 99 times out of 100, you won't be given any units, so you need to include that at the end, okay. Right, next one, y equals x squared. X-axis. And the line x equals 3. So they're the bounds. We need to find the area enclosed by those conditions. Okay, so quick sketch of the area. And that will become apparent very soon while we need to do this. So x. Alright, so y equals x squared is a what? Parabola. Now looking at this, x-axis, x equals 3, so just really need to draw the parabola in the first quadrant. Okay, just a rough sketch, so I know what it looks like, and I know what I need to do. And there's the line x equals 3. Okay, so the other end of the bound will be at 0, because that's the, of course, will be the end of the area underneath the curve and the x-axis. So I'm finding that shaded region there. Okay, it won't tell you to set up an integral, so you need to know that you need to set up an integral to find the area. So capital A for area is equal to the integral from the highest bound point to the lowest bound point of the function. So this is f of x is x squared. And then dx you need to write at the end because you're integrating with respect to x. Alright, so what this does, okay, so we talked about the approximation method. We've taken lots of little rectangles in there, and the shorter width we make the rectangles, the more accurate the area is going to be. Okay, so in other words, we're taking the limit as the width of that rectangle approaches 0. When it approaches 0, we're going to have the exact area under the curve. Alright, and that's what this does. Alright, so you don't need to know that business there and how it's worked out, but that's just what we're doing. What you guys need to be able to do is this. Alright, you need to show me that yes, you know you need to integrate, you know how to integrate, you know how to substitute into the primitive function, and then you can tell me what the area is. Alright, what is the integral of x squared? Okay, so add 1 to the power, divide by your new power. Alright, then put your parentheses, and then the endpoint. Go at the end of that. Alright, so equals 3 cubed over 3. And then when I substitute 0, okay, I know this whole thing's going to go to 0. So I don't need to show that whole substitution, I can just write 0. Alright, when I know it's going to be 0. Alright, so this is really 3 to the power of 1. So we've got the index clause, 3 to the power of 3, divided by 3 to the power of 1, we do a subtraction of the indices, 3 take away 1, which is 3 to the power of 2. Okay, so applying your index clause again. So the exact area underneath the parabola, y equals x squared, between x equals 0 and x equals 3, is exactly 9 units squared. Okay, so even though there's a curve, alright, we've got an exact area, a whole number, sorry, for the area. Which, yeah. Alright, C. Any questions so far? Everyone's understanding, everyone's following? find the area enclosed by the curve, y equals h cubed, the x-axis, and the line x equals -2 and x equals 3. Alright, so we've got a cubic, h cubed, x-axis, and x equals -2, x equals 3. And this is why you need to draw the sketch. Alright, so you should know what a cubic looks like from your prelim course. Okay, got x equals 2 and x equals 3, so I'm going to have either side of the origin. Alright, you need to know what your functions look like, and we've done a whole topic of that to prep you for this. So all your function skills, so sketching all your functions, you need to be able to do that, so you can accurately sketch the area. Good representation of the area to be found. Okay, so we've got x equals 3 and x equals -2. Alright, so what we need to do is find between the curve and the x-axis the area that's just been shaded. Right, so can you now see why I've asked you should be sketching the area to be found? Okay, so can someone describe to me why we need to do this?
It's a negative, so it'll come up as a negative.
Okay, when you find the integral of this, okay, you are going to get a negative area. Right? When you find the integral of this, you are going to get a positive area. If you just go ahead and write down the integral from 3 to -2 of h cubed dx, what you're going to do is you're going to have this part of it cancel out because we've got symmetry with the cubic, right? So between that dotted line and the axis, this area is exactly the same as this area here. Okay, now this is a negative area, okay, because this will return, the integral will return a negative value. All you've really done is found the area between 3 and 2 if you just substituted the integral from 3 to -2. Okay, so that's why you need to sketch the area to be found. So, what's the suggestion on how I'm going to get around that? Yep, and what else do I need to do?
Break it up into 2 different things.
Good, break it up into 2 different areas. So the area above the axis, area below the axis, and then add them together. Alright, so the area is going to be the integral from 3 to 0 of h cubed dx. So we're just on the positive side here in the first quadrant. And we need to add the absolute value, because this is going to give you a negative integral if you just integrate. Okay, from the highest point, which will be 0, and the lowest point, which is -2. Now, there is a difference between it asking you to calculate the area here and if the question asks you to do that. Evaluate the integral. Alright? They are 2 different questions. Okay? So if the question paper gives you that, or your exercise gives you that, you perform the integration as it is there. Okay? When you ask for the area, this is where you need to break it up. Alright? Because you're asking specifically about the total area that's bounded by the curve. Alright. Integral of x cubed is,
X to the 4 over 4.
add 1 to the power, x to the 4, divide by your new power, multiply by any constant, of course, from 3 to 0, plus, now it's going to be the same integral, from from 0 to -2. And we're going to take the absolute value of that. So, equals, so substituting 3 for x, it'll be 3 to the power of 4 over 4. Take away, again, if I substitute 0 in here, I'm going to get 0 for that function. And then I'm going to add the absolute value of, again, so substitute the highest point, which will be 0 again. Take away, bracket, a negative 2 to the power of 4 over 4. I'm going to take the absolute value of all that. Alright, so 3 to the power of 4 is 81, 81 over 4. Take away 0 plus the absolute value of negative, so negative 2 to the power of 4 is 16, so it'll be 2 squared or squared. And that's why we need to take the absolute value, because if we just did the integral, we would get a negative answer. Okay, so it'll be 81 on 4 plus 16 on 4. So 20 and a quarter plus 4, so we're going to have 24 and a quarter units squared. Okay, you can represent it as the improper as well, or decimal, that'll be fine. The question is specify. Usually we just leave them as improper, okay, but it's not crucial that you do. Okay, any questions about the understanding of how to set up C? Okay, so everyone's following what needs to be done. Alright, one more. Okay, and this is where a question like this is where you need to know your functions and graph skills, because sometimes you will need to do an extra piece of working out before we can go and answer the question. This board's absolutely shocking. Okay. Find the area enclosed by the curve. So d y equals x squared. Take away 6x plus 5 and the x-axis. Okay, so this is where the skills that's been taught in functions and graph is applied so that you can do integration.
Does it have a balance? Or?
Pardon? To find the area of the curve between
Infinite.
that function and the x-axis.
That's infinite.
Bound.
It's not enclosed. Is it? It's not enclosed. It's infinite.
Infinite?
Infinite.
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 It's infinite. 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 It's infinite. Infinite.
Potato, potato.
Yeah.
Tomato, tomato.
Infinite.
Infinite.
Infinite. Infinity.
I'm going to say infinite from now on. It's infinite.
Infinity.
Infinite. Infinite.
Infinite.
Alright, so,
Infinite.
okay, so the area is not infinite
Why? How is it not infinite?
Infinite.
because we are bound by
Oh, so
a curve
it's
and an
like
axis.
upside down or something.
No, it's not sorry.
Right, so, how am I going to know where the endpoints of the integration is going to be?
Where it
Can't you
chops
do
the
that?
x-axis.
Where you...
It's x intercepts.
Yeah, no, he's right.
Yeah, I just
You
wanted,
don't know
wanted
how
you
to
to
do
say
it.
it though.
Teaching
It's going to be 5
Oh,
mile.
no.
Negative 5,
the
negative 1.
endpoints.
No, just trace it that way.
Negative 5, negative
Please.
1.
Please,
Yeah.
please.
Yeah.
So, how do I work out this negative 5, negative 1?
Get the roots.
Find the roots. Okay, which is what we learned in chapter 5, sketching the parabola. So, x squared take away 6x plus 5 is 0. So we're finding the x-intercepts. When we find the x-intercepts, we will have where the curve crosses the x-axis, and we also then have where it's bounded. Alright, two numbers multiplied to give positive 5, same two numbers add to give negative 6.
She said that like. Whoa.
Think before you speak. Alright, so x equals 5 and x equals 1 is the actual point on the x-axis where the parabola crosses. Okay.
Why are you still bowling? Seriously.
What?
Okay, so why can't we say the area is infinite, Robin?
Who wouldn't eat the pizza? You would have eaten the pizza.
I don't eat. I'm like really picky when it comes to food. It's been in the fridge for like a week.
Yeah, but if you didn't know that it had been in the fridge for a week.
Anyway, back to maths.
I would.
So, when the question says that the area is bounded by a curve and the x-axis, you need to find the definite area, not the indefinite area. Okay? So yes, you can argue the point that there is going to be an infinite area because the curve keeps going. Okay, but because we are not bounded and we are having bound when we find area, okay, then we need to only find where the curve is bound and the x-axis. Alright, so the area is going to be the integral from highest to lowest of the function, so x squared, take away 6x plus 5. I'm going to integrate that with respect to dx. Is there anything else I need to do before I integrate? Alright, I need to put the absolute value symbols there because you're going to have an indefinite integral. So in other words, the area is going to come out as negative and we want area to be positive. Alright, so the first one we've got 3 terms, alright? So previously we had 1 thing we need to integrate. We now need to do 3 terms. Alright, so integral of x squared. Okay, so x cubed on 3. Integral of negative 6x.
6x to the... No, it's 3x.
So 6x squared over 2. Don't take shortcuts unless you know. And then the integral of any constant number is 5. Okay, so then we can cancel our work. Right, from the endpoint 5 and 1. And we need to take the absolute value. Okay. So 5 cubed on 3, take away 3 lots of 5 squared plus 5 lots of 5. Okay, so I'm substituting 5 for those 3 terms. I'll then need to do take away, open bracket. And again, I know that it's 1, okay, so I don't need to write 1 squared, 1 cubed, etc, etc. Alright, I can just put 1 in there. So third, take away 3 plus 5. Okay, so I can just write that. I don't have to be nitpicking every little bit. Okay, you can if you want. You don't need to. Alright, so at this point you put that in as it is on the board into your calculators, or you need to work it out using math skills.
Wake up and do your goddamn math.
I'm doing my work.
41.6666666. Take away. No, let me colour. Just let me
Is
colour.
that the overall answer?
I don't know.
No, that's just the first bit.
Yep. I'd put it all in one time, one calculation.
The whole thing. Go down.
3.25.
Okay, 32 over 3. Alright, so the calculator said negative 32 over 3. Alright, so again we need to take the absolute value, which is 32 over 3 units squared. Okay, and that is the exact area underneath the
That's so cool.
between the curve and the x-axis. Question.